We're going to look at end behavior of polynomial functions. So first, we're going to look at the ax squared plus bx plus c is just a quadratic, and we kind of know what goes on there. But what I have here, and I have the activity in Schoology that you can launch and look at yourself. But what I'm going to do is change the values of a, b, and c. And I notice really quickly, and you may probably have seen this before, but as I make a larger, all right, all that does is stretch the function itself. When a goes negative, we see that the parabola flips. And that's all we really need to notice. Now, once again, if we change the value of b, which is the x term in my equation, it really doesn't change which way the graph flips, but I do see one thing staying the same. All right, so b has a effect on the orientation, but really not much else. C, hopefully you can see this now, c is the constant term in my quadratic, and when c is 3, notice the actual y-intercept is 3. When c is negative 3, all right, so you can change those things around. Now, I want you to notice one other thing is whenever a is 0, notice in the equation ax squared plus bx plus c, if a is 0, then there's no squared term. So this is just bx plus c, which makes it a linear equation. And you know, we know what happens there. Obviously, we move our c up, that's just the y-intercept, right? So what we'll do is take that information back to our notes here and look at what happens at a quadratic function. And let's look at this, what we call end behavior. The first thing we realize is that these, I'll put an arrow here and an arrow here, meaning that those that curve is going to go on forever in both the x direction and the y direction. So the way we describe this, first off, we realize in this case that a, or the leading coefficient, is greater than 0, positive. So if the leading coefficient is positive, then the graph opens up, the graph of the quadratic. And we'll talk about what happens when a is less than 0. The next thing we know is that that point right there is the value of c. All right, the y-intercept is c. The next thing is, let's talk about these, what we call end behavior. So look at this arrow. What does that really mean? Well, the way we say it mathematically is the limit, and we abbreviate that LIM. So the limit, and we say as x goes to infinity, we say the limit of f of x also goes to infinity. All right, and let's look at this end. Notice we're looking at it that way. So now we say the limit, all right, I'll write that a little better. The limit as x goes to negative infinity of f of x. Still, we're going up, you know, larger and larger positive infinity in the output. So that one goes to infinity. It's positive infinity. Okay. So let's look at that. So a is leading coefficient. So if a is greater than 0, the parabola opens up, and we say things like the limit of f of x as x goes to infinity equals infinity, and the limit of f of x as x goes to negative infinity is still positive infinity. Okay, looking at quadratic functions here, continuing on. In this case, okay, since my parabola is pointing or opening down, we know that a, or the leading coefficient, is less than 0. And then let's talk about this end behavior, noting before I even do that is still c. All right, this end behavior, so we're saying the limit, and we're looking at x going that way. So the limit as x goes to positive infinity of f of x equals, in this case, negative infinity. And over here, the limit as x goes, we're looking that way now, x goes to negative infinity of f of x. Once again, we're going down, so that's negative infinity. Okay, you might want to look at that over again. So the limit as x goes to infinity of f of x equals negative infinity, and the limit of f of x as x goes to negative infinity equals negative infinity. So in both of these, the end behavior is going in the same direction. Since the parabolas open up, both sides of the parabola go off to positive infinity. As soon as we have a leading coefficient that is less than 0, we flip the parabola, and then each sides of the parabola go off to negative infinity. Now let's look back at a cubic function. All right. So now I'm going to turn off my linear function and turn on my cubic, and we know that it has that general shape. Now, the big thing to see is that when I change b, it really doesn't change the general shape of the graph unless it's in behavior. C, you see if you slide C up and down, C is now 4, so the y-intercept is 4, so that doesn't really change anything. But let's look at A, right? Got A is 0, oh, it's back. It's not a cubic anymore, it's a quadratic, but if I make A negative, see how the graph flips, right? And look at that end behavior. Negative, positive, all right? Let's just take that together and go back to our notes. So this is your basic cubic function in this case. When the leading coefficient A is greater than 0, we know the general shape of the graph is like that. All right, noting that that's C. And then let's talk about the end behavior. Right there, this is saying the limit as x goes to infinity, the limit of f of x goes to positive infinity. But back here, the limit as x goes to negative infinity of f of x, it goes to negative infinity. So different. Write that again. So the limit of f of x as x goes to positive infinity for a cubic, when a is greater than 0, leading coefficient is positive, then the limit goes to infinity. But when we look at as x goes to negative infinity, the limit of f of x goes to negative infinity. And we saw here that when a was less than 0 or negative, then the graph kind of switched. All right, and now we can talk about those end behaviors here. Okay, when the leading coefficient is less than 0, the limit as x goes to infinity of f of x, it goes to positive infinity. Make sure I get rid of that little mark there. And over here, the limit as x goes to negative infinity goes to positive infinity. So we always look at what happens when x gets very large, positive, versus what happens when x gets very large, negative. And just analyzing the arrows, I can fill in that information. All right. Now the next thing, so we know about quadratics, we know about cubics, and if you understand those two, you're good to go because the pattern repeats. And I go back here, all right, I keep the same graph. Now instead of looking at a cubic, I'm going to look at a fourth power. Notice the A is on the leading coefficient, C is at the end still. So once again, if I move C, all that's doing is moving the y-intercept. B changes, the kind of the shape of the graph, but it doesn't change the end behavior or the y-intercept. And now I make A large negative Uh-oh, it flipped. That makes sense. It just flips. Just like it did in a cubic, just like it did in a quadratic. And just to convince yourself, when you make it, when a is 0, that gets rid of the fourth power term. So now you're looking at a cubic. All right. And I'm just going to keep moving on. I look at a to the 6th power. All right, changing 3, or changing c just changes the y-intercept. B changes the general shape, but it doesn't change the end behavior. And now the end behavior, when a is positive, looks like it has the same kind of end behavior as a quadratic. When a is negative, the same thing.
More like a